Hello, Latin geometry students. In this assignment, we are going to talk about the converse of the Pythagorean theorem and the Pythagorean inequality. That's a lot of words for just a couple extra tricks you can do with the Pythagorean theorem. See, the Pythagorean theorem, as you've learned it, is that when we have a right triangle, we can use this formula. If you have a right triangle, then a squared plus b squared equals c squared works. But this statement is biconditional. That means if I switch the order and do the converse, another old word, if a squared plus b squared equals c squared works, then it's a right triangle. This is true as well. That's what we call biconditional. If you have a right triangle, then the formula works, or if the formula works, then it's a right triangle. So this statement works either way. If you have a right angle, you can use the formula. If you can use the formula, then it's a right angle in your triangle. Basically, that means we can use the Pythagorean theorem not only when we know we have a right triangle, using it to find a missing side, but if we know all three sides, we can determine whether it was a right triangle in the first place. For example, here's a problem. We got a triangle. There's a question mark here. We don't know if it's a right triangle. Maybe it is. We can, since we know all three sides, we can figure out if that was a right angle. How? By doing the Pythagorean theorem with these numbers. If it works out, then this is a right angle. So the way you do this, and the question you'd be asked is, you'd see a picture like this, and you'd be asked, is this a right triangle? So step one, you pretend you don't see the hypotenuse. So we're going to block this out so you can barely see it, but we're going to pretend we don't know that the hypotenuse here is 13, or maybe it's not a hypotenuse. But what we will do is do the Pythagorean theorem with the 9 and the 11. And if it's a right triangle, we should get 13 for that missing side. If we get something else, then it's not a right triangle. So we go ahead and do the Pythagorean theorem with the two legs that we have, 9 squared plus 11 squared. And this is where you bust out a calculator. 9 squared plus 11 squared turns out to be 202. And then we take the square root of that, and it comes out to 14.21. Now that number is what the hypotenuse is supposed to be if it's a right triangle. But we got this number instead. Is this 13 correct for a right triangle? No. Because these two numbers don't match, it is not a right triangle. So all we did is we ignored the hypotenuse and did the Pythagorean theorem with the two legs. If the number we get for the hypotenuse matches what we're told, then it's a right triangle. If it doesn't match, then it's not a right triangle. In fact, we can actually also use this to tell if the triangle is acute or obtuse. See, this 14.21, that's what we're supposed to get. But this 13 right here, this is too small. What happens to a triangle if we make the hypotenuse too small? Well, we start with a right triangle, and now I'm going to take that hypotenuse and just shorten it up a little bit. In order to complete this triangle without changing the lengths of the sides, we have to bend this one side in a little bit. But by doing that, we make this angle a little bit smaller. So when the hypotenuse ends up being too small, we lose our right angle. It becomes an acute angle. So if the hypotenuse is too small, we have an acute triangle. Likewise, if our hypotenuse is too big, let's take the hypotenuse of this triangle and make it too big. Now to make this triangle work, we're going to have to bend this angle outward. If you look here, this angle becomes more than 90 degrees. So if the hypotenuse is too big, the triangle has to be obtuse. Now, if we look this up in a book, it'll write this out looking like this, where we have a squared plus b squared equals c squared means it's a right triangle. If the c squared is too big, it's obtuse. If the c squared is too small, it's acute. Now, this is a lot of words to remember here, but basically, if the hypotenuse is too big, it's obtuse. If the hypotenuse is too small, it's acute. If the hypotenuse is just right, it's a right triangle. So in each of these problems, we want to decide is the triangle acute, obtuse, or right. So again, what we're going to do in the first problem is we're going to ignore the hypotenuse. We're going to pretend we don't see the 17, and we'll do the Pythagorean theorem with the 8 and the 15. So we do 8 squared plus 15 squared. We get 289, and then we take the square root, and it turns out that it is 17. Hey, these numbers match. What does that mean? What kind of triangle is it? That's a right triangle. These numbers follow the Pythagorean theorem, which means it's a right triangle. But in the other two problems, they won't. We use the same two legs, and we're changing the length of the hypotenuse. So in this case, if we do the Pythagorean theorem, it's the same problem. We're supposed to get 17. 17 is the number that will make it a right triangle. But this is not 17 in the picture. It's 18. This 18 is too big. And since this number is too big, that means the triangle is obtuse. In the third example, we do the same thing. We still have the 15 and the 8, so doing the same problem. We get that the hypotenuse is supposed to be 17, but it's not in this picture. It says 16. This 16 is too small. If it's too small, that means the triangle is acute. That's basically it. These problems are not very hard, especially if you already know the Pythagorean theorem. But there is one mistake people tend to make, one really common mistake, and it's a very small mistake. And if you get this part wrong, the whole thing is incorrect. See, here's a problem on the left. We have a triangle with sides 20, 30, and 40. And we were trying to decide if this is a right angle or not. So someone came over here and they did all the work, 20 squared plus 30 squared, and they took the square root and they got 36.01. And now they look at our two numbers and they say, okay, is the 40 too big or is the 36 too small? Which one is the wrong one? And the thing you have to remember is the number that you calculate is the correct answer. It's supposed to be the number that you get when you do the calculations. In this case, it's supposed to be the 36. It's the number that we were given that is either too big or too small. The number that was in the picture in the original problem that's too big or too small. And in this case, that 40, wow, that's too big. So that means this triangle would be obtuse. So determine if this triangle is acute, obtuse, or right. Okay, if you set this one up, we do 15 squared plus 22 squared and take the square root. We end up getting 26.6. It said 28. Oh, that 28 is too big. That means this triangle is obtuse. If we try this in this another problem, there we go. For this one, determine if this triangle is acute, obtuse, or right. Okay, so we apply the Pythagorean theorem with the 12 and the 18. We know the 20 is the would-be hypotenuse because it's the biggest number. 12 squared plus 18 squared, and then take the square root, we're going to get 21.6. But this 20 here, that's too small. That means the triangle is acute.